the switch port that we have, a layer 2 port that we have, it can operate in access mode or a trunk mode. A switch port mode. Switch port can have two types of mode, administrative mode and operational mode. Right here, if you see, if you use the command, so interface switch port, you see right here, administrative mode and operational mode. A switch port has something called an administrative mode, and a switch port has something called an operational mode. Administrative mode means how the network administrator has configured the switch port to operate. How the network administrator has configured this switch port to operate. And the operational mode means how the port is actually operating. Operational mode can be only access or trunk. Like either the port will operate as an access port or the port will operate as a trunk port. Either the port will operate as an access port or the port will operate as a trunk port. There is no in between. The port will be either operating as the access port or the trunk port. But when we talk about, for example, how the port is configured to operate as an access port or the trunk port, how the network administrator has configured the port to operate as an access port or the trunk port, that is there. That is what we call the administrative mode. So a port can be configured to operate as an access port by doing the configuration manually. A port can be configured to operate as a trunk port by doing the configurations manually. Static access, static trunk means like, manually we have configured the port to operate as an access port or the trunk port. Dynamic auto, dynamic desirable. Here we use a protocol, Cisco proprietary protocol called DTP, Dynamic Trunking Protocol. We can use the protocol DTP to dynamically choose the port as the access port or the trunk port. We can let the switch select or choose the port to be either as an access port or the trunk port. Automatically. I can let the switch decide if it has to put the port in the access mode or the trunk mode automatically. There, we use a protocol called DTP, Dynamic Trunking Protocol, which is again a proprietary protocol, and VTP is also a proprietary protocol. So administrative mode defines how the administrator has configured, how the admin has configured the port to operate, how the port is configured to operate. Is the port is operating as an access port? Why? Because the administrator has configured it to do so. The port is operating as a trunk port. Why? Because the administrator has configured to do so. The port has decided to act as an access port or the trunk port automatically. That is based on the configuration of protocol called DTP. DTP works in two modes called dynamic auto and dynamic desirable. So if someone asks, like, by default, a Cisco Catalyst switch port, is it an access port or a trunk port? You cannot actually answer it. Right? Like if we go via practical approach, by default, all the Catalyst switches, they implement DTP on all the interfaces by default. I don't need to configure the DTP. DTP is running by default on all the switch interfaces, switch ports by default. You can check that as well. If you want to check it, the command is show DTP on interface, whatever interface you want to check. Gigabit 1x0x1, 1x0x2, 1x0x3, whatever interface it is. So if the interface is up, you will be able to see the status of DTP onto that particular interface. Do we have like that? So this is one interface that is up. This is one of the interface that is up. So no need to worry about what is written there. Just understand that DTP is running. We got some output. It just means that DTP is running. I do not care about the output. So this port by default, or all the switch ports by default, you see, show interfaces, Ethernet 0x0, switch port. All the switch ports by default, they run DTP. By default. See, show here, interfaces, gig 1x0x1, switch port. This port is down at the moment, but it is running by default DTP. So you cannot say if the port is operating as an access port or trunk port, because by default Cisco Catalyst switches implement DTP, dynamic trunking protocol, and DTP automatically decides if the port has to be an access port or the trunk port based on what is connected to it. A switch can be connected to a switch operating in the access mode, operating in the trunk mode. Based on that, this will become either access or this will become trunk. A switch port can be connected to a PC access. PCs, they do not act as a trunk, so this will become an access port, something like that. So the point is, you cannot say that the port is acting as an access port or a trunk port by default, because that configuration is dependent, or that thing is dependent on DTP. By default, Cisco Catalyst switches, they run DTP on all the interfaces. Either they will be in dynamic auto or dynamic desirable mode. Most of the Catalyst switch platform, they come in dynamic auto. Some switches are there in dynamic desirable mode as well, but most of the Cisco Catalyst switches, they come in dynamic auto mode. That means like they will choose if the port is going to be access or trunk automatically. So based on the administrative configuration, how the port is operating, that is defined in the operational mode. So either the port will operate as an access port or the port will operate as a trunk port. Either the port will operate as the access port or the port will operate as a trunk port, and how, that is defined under the administrative mode. So remember, when we configured the port here, when we configured in this topology, when we configured this port in VLAN 10, VLAN 20, we actually still did not disable the DTP. That means if I go on switch number 1, I go to the port number 0 by 0, I can see that the port belongs to VLAN 10, but the port is operating as an access port. Port is operating as an access port, not because we have configured it in VLAN 10. No, the port is operating as an access port because it is connected with a device that is not capable of negotiating the trunk using DTP. See, this administrative mode is still dynamic auto. That means if someone disconnects your PC and connects a switch here and configures its port as a trunk port, you will become trunk automatically, no matter what VLAN membership you have configured there. So this command, what I'm trying to say is that this command doesn't mean that the port has become access port. No, this doesn't mean the access port. It's related with data, that this port belongs to the data VLAN 20. But is this port access port or the trunk port? At the moment, the port is acting as the access port. At the moment, the port is operating as the access port. At the moment, the port is operating as the access port. Why the port is operating as the access port? Because the device that you have connected onto that port is not capable of running DTP, or that is acting as the access port. Device is in the access mode. So if I remove that particular host machine, and I configure that, I connect a switch there, you will notice, and I form a trunk there, you'll notice that your port will become trunk. So the point is, if you know that the certain port is going towards a single device, if you actually want to configure the port as an access port, if you want to configure the port as an access port, you also need to use this command: switch port mode access, interface Ethernet 0 by 0, switch port mode access. Switch port mode access means I have administratively configured the port to become the access port. And then this port belongs to VLAN 10 and this port belongs to VLAN 20. Now the DTP is disabled. Now you notice, see, earlier it says that the port is in VLAN 10, but I will negotiate for the trunk because we are in dynamic auto mode. But now if I check show interface Ethernet 0x0 switch port, now you check here, static access, trunk negotiation is off. So if you want to disable the DTP onto the interface, just configure the port as the access port. If you configure the port as the access port, DTP will turn off onto that particular interface, and the port will become part of a certain VLAN. So these two commands you should use, not only this command, because if you use just this command, the port will become part of VLAN 10, but it will remain part of VLAN 10 until it becomes trunk. If someone removes that PC, connects a switch, forms trunking, you will notice that this will also become trunk, and your VLAN membership will be of no use. So to more like harden, to more like ensure that the port remains as an access port, it does not negotiate for the trunk, we are going to actually configure command switch port mode access. Right? So what is static access? What is this mode, access mode? Access ports, they belong to one specific VLAN, like interface, switch port mode access. So this port we have configured as an access port, and the port belongs to VLAN 10 for data traffic, VLAN 20 for the voice traffic. So access ports belong to a specific VLAN. Typically from the access ports, end devices are connected, such as PC servers, access points. It will only forward the traffic for that VLAN, which is assigned to that particular port, and it can only be member of a single VLAN. So if the port is an access port, it will become part of one particular VLAN. It will send and receive the data for that particular VLAN only. How to configure the port as an access port? This is how we configure the port as an access port. And whatever traffic exits out of this particular interface, no marking is done. Like there is no indication onto that frame. There's no indication onto that frame. There's no indication onto that frame that exits out of this particular interface. There is no indication on that frame that, okay, the frame belongs to VLAN 10. No tagging, no indication is there onto the data exiting out of the access port that the data belongs to VLAN 10. Like if the data exits out of this particular interface, I know that the data belongs to VLAN 10, but I'm not going to tag it. I'm not going to add any such information that represents that the data belongs to VLAN. Tagging is not done on the access port. So access ports are those ports where the end users are connected, end devices are connected. They belong to one VLAN. They will send and receive the data for that VLAN only. Right? And the traffic that exits out of the access port, it is not tagged. There is no information onto the data that exits out of that particular access port that the data belongs to this particular VLAN. There's no such adding of the information onto the same. No. Any traffic that comes onto the access port or it exits out of the access port, it's never tagged. Traffic received on the access port, traffic being sent out of the access port is not tagged. Tagging is not done on the access port, no matter if you receive or send the data. Tagging is always done on the port called trunk port. So if the port is operating as the trunk port, then the tagging will be done, but the tagging will not be done on the access port. No, you cannot have multiple VLANs onto the same port. We can configure the port in only one VLAN, and the data will be passed only for that particular VLAN. A port can behave that it is acting. A port can behave that it is acting a part of in multiple VLANs only when it is operating as a trunk port. So by default, trunk ports, right? Trunk ports allow the traffic for all the VLANs. They send the traffic for all the VLANs. They receive the traffic for all the VLANs. So it looks like the port is part of all the VLANs, right? So I can configure the switch port mode trunk, and then I can allow only VLAN 10, 20, and 30. So it would look like that the port belongs to multiple VLAN, but not, you cannot do it by making it an access port. If the port is access port, it will remain part of one single VLAN. Right? Which brings me to a very interesting question, which you might have seen floating around in, LinkedIn interviews and all. Very popular question. Very popular question. So, which two devices will communicate in this case? In this case, which two devices will communicate? So, traffic will be generated by device A, sent to the switch, received onto the port that belongs to VLAN 10. Traffic will be sent out of all the ports in VLAN 10. So this port is there in the VLAN 10. Traffic is going to exit out of that port, received onto this port. There is no tag or anything. There's no tag or anything. So when the traffic arrives onto this port, it will be assumed that the traffic belongs to VLAN 10. Why? Because the port on which traffic is received is there in VLAN 10, and the traffic will be sent out of the ports in VLAN 10. So it's more like a VLAN 10 broadcast domain. So A and D will be able to communicate to each other. If I configure VLAN 20 here, if I configure VLAN 20 here, then what two devices will be able to communicate to each other? It will be like B and C. B and C will be able to communicate to each other in this case. Because VLAN 20, VLAN 20, VLAN 20, VLAN 20, so it's more like a VLAN 20 network. So there's no tagging here. We have not talked about VLAN tagging. There is no tagging here. The traffic sent out of the VLAN access ports, it is not tagged. So it will be just forwarded as it is. Traffic arrives here, exits here, no tag, receives here. Since the traffic is received onto the port that is part of VLAN 20, it will be assumed that the traffic belongs to VLAN 20, and traffic will be forwarded out of all the ports in VLAN 20. No tagging, nothing. Access ports, they don't have the concept of tagging. Port arrives onto the port is configured as an access port, traffic will become part of the port, traffic will become part of the VLAN configured onto that port. As simple as that. No tagging, nothing. Right? So it's okay. Now, the point is, if I configure this in VLAN 10 and I configure it in VLAN 20, then how the communication will happen? Is it an error? Can it happen? Is this topology okay or not? What traffic will go in this case? What traffic will be passed in this case? Considering that everyone is in the same broadcast domain. 10.1.1.1, 2, 3, 4. So traffic, this device sends the traffic from A to D here. Traffic arrives onto this port. This port belongs to VLAN 10. It is an access port, belongs to VLAN 10. So traffic will exit out of the port that is part of VLAN 10. Out of these two ports, which port is part of VLAN 10? This port is part of VLAN 10. So the traffic will exit out of this port. There will not be any tag or any information on the data that says that the traffic belongs to VLAN 10. Traffic will be received onto this port. Traffic is received onto a port that is an access port configured in VLAN 20. So the traffic cannot go from this port to this particular destination. That means this communication will not happen, even though these belong to the same VLAN. Right? Similarly, now I ping from A to C. Traffic arrives onto this port. Traffic belongs to VLAN 10, exits out of the port in VLAN 10, received onto this port. This port belongs to VLAN 20, so the traffic can exit out of the port in VLAN 20. That means your communication will be successful. That means I will be able to ping from A to C. And of course, when the reply comes, traffic will be received onto this port, belongs to VLAN 20, exit out of this port because it belongs to the same VLAN, received onto this port, which belongs to VLAN 10, and it will be sent out of the port that belongs to VLAN 10. So the communication will happen from the user in VLAN 10 with the user in VLAN 20. It's not inter-VLAN routing, by the way, just in case if you are wondering. It's not inter-VLAN routing. It is not called inter-VLAN routing. So yes, VLAN 10 can communicate with VLAN 20 user in this type of situation. Same if I put the port in VLAN 20, if I put this port in VLAN 10, then 20 to 10 communication will start happening. Doubts? Let me know. Doubts? Yes, if like all these devices, they are in the same subnet, then only this will happen. Otherwise, this will not happen. So 10.1.1.1, 2, 3, 4. Of course, like, so of course, A and B will not be able to communicate because they belong to the different VLAN. They will not communicate to each other. If it is in VLAN 10, VLAN 10, VLAN 10 will communicate. If it is in VLAN 20, VLAN 20, VLAN 20 will communicate. Yes, they will communicate only when they are in the same subnet. If everything is in the same subnet, then only this thing will happen. But if I put this port in VLAN 10 and I put this port in VLAN 20, all you need to understand, all you need to forget actually, all you need to forget is the concept of tagging here. All you need to forget is the concept of tagging here. There is no tag in the access ports. Traffic arrived onto this port. This port was an access port. Traffic becomes part of VLAN 10. And traffic will exit out of the port in VLAN 10. When the traffic exits out of the port in VLAN 10, there is no tag. So this switch has no idea. This switch cannot possibly know that the data belongs to VLAN 10 or 20. More importantly, when the traffic arrives onto this particular port, this is also an access port. This is also an access port. And if it is an access port, the data becomes part of VLAN 20, and the data will be forwarded towards the user in VLAN 20. This is how it happens. So this VLAN 10.10 broadcast domain, 20.20 broadcast domain, traffic exits here, received here. Simple. I mean, not that simple, but it is how it happens. You have to consider these two ports part of the same broadcast domain. You have to consider these two ports part of the same broadcast domain. So whatever traffic arrives here, it can exit on here. Whatever traffic arrives here, it can exit on here. Condition, all they both belong to, they should belong to the same broadcast, same subnet actually. It is not inter-VLAN routing, however. Yes,
Hi, sir. Yes, am I audible?
Yeah.
Okay. Once we received the traffic VLAN 20 and second switch, why it is not exit to the VLAN 10? So it is inside,
Because VLAN 10 and
it's
20
not
cannot
tagging.
communicate.
No, so that is right. So the VLAN tagging won't be happen. So whatever traffic we received, so this should go to 10 also, right? 10 and also it will not tag, right?
No, you don't understand. On this switch, we have configured the port in VLAN 20. This port is configured on VLAN 10. So whatever traffic is received onto this particular port, whatever traffic is received onto this port, it becomes part of VLAN 20, and it can now only exit out of the ports in VLAN 20, not in VLAN 10. That separation is still there. No? On this switch, on this particular switch number 2, switch can clearly see what port belongs to VLAN 20, what port belongs to VLAN 10. So it will still not allow the communication between 20 and 10. That communication is allowing the communication from 20 to 20. This is not inter-VLAN routing. It is one of the most popular questions that they ask in the interviews, and also I thought like we should discuss it. It is not inter-VLAN routing. Why it is not inter-VLAN routing? Because for routing to be done, the traffic has to move from one subnet to other subnet. And are we moving the traffic from one subnet to other subnet? No, we are moving the traffic from the same subnet to the same subnet. It's not inter-VLAN routing. It makes sense actually. It is used in a few conditions. This type of deployment has been done in a few conditions. I hope I can tell you the use cases of it. This thing has been used, or you can use this thing in some situations. I can actually, explain it a little bit more. There are two companies, there are two organizations, right? There are two sites. You have two sites. This is site number 1. This is site number 2. There are users in VLAN 10, VLAN 10, VLAN 10. There are users in VLAN 10. They are able to communicate to each other, but they want to access the resources in VLAN 20 there. There is a server in VLAN 20. There is a server in VLAN 20. This server is accessible to everyone in this site here. This server is it is accessible to everyone in VLAN 20 here in this site. And the users in VLAN 10 wants to access the servers, let's say, for example, in VLAN 20. You can say that we can go ahead with the concept of inter-VLAN routing, completely fine. But the users in VLAN 10, they have subnet this, and users in VLAN 20 on the second site, they also have the same subnet. Why? Because these were two different sites. There was no connection in between them. So whatever subnet was being used here, same subnet is being used here. We can use the private IPs wherever I want. Now, go ahead and do inter-VLAN routing. Try to perform inter-VLAN routing. You cannot perform inter-VLAN routing. How are you going to fix this problem there? There are users. What I said. There are users in site A. There are users in site B. Users in site A belong to VLAN 10, configured with the subnet. There are users in site 2, belongs to VLAN 20 in this subnet. There is a server. This is a server that is accessible to everyone in site 2 because it also belongs to the same VLAN. Now, due to some reason, for 10-15 minutes, for one day, I want that these users should be able to access the services of that server. And I cannot perform inter-VLAN routing. Why? Because the subnet that is being used in these two sites, it is exactly the same. Routing, inter-VLAN routing only makes sense when the subnets are different. So all I need to do is to just connect this like that, put this port in VLAN 10 and put this port in VLAN 20. The users are going to send the traffic. It will arrive onto the switch port. These are access port, access port, access port, belongs to VLAN 10. So the traffic will become part of VLAN 10 and can exit out of the port in VLAN 10. However, no tagging is done on the access port. So this switch is receiving just data without any tag. How does it see this? This switch is going to see it like that there is a PC sending me the data. In the same way, it is going to see it. When the switch receives the data onto this port that belongs to VLAN 20, it will allow the communication in VLAN 20. I hope it makes sense now. We can leak the traffic data of one VLAN into another VLAN with the help of this kind of deployment. It is done. I have seen in a few documentations that this kind of deployment is done in a very small scale business where a few sites were there and they just wanted to access some resources from one to another. Instead of changing the subnets, performing the inter-VLAN routing, just need to do this. Forget about the tagging concept. There is no tagging on the access port. So the data arrives onto the port. Port belongs to VLAN 20. The data will become part of VLAN 20. That's it. No tag. And if the port belongs to VLAN 20, the data can exit towards the ports in VLAN 20. Simple. So you can try to test it just in case. If you want, you can try to test it in this scenario, in this environment. You can try to test it just in case if you want. Here, you can try to test it. VLAN 10, VLAN 20. Put this in VLAN 10 and put this in VLAN 20 and see what happens. Or just create this simple topology, the same topology that I just explained to you. Just create the simple topology, VLAN 10, VLAN 20, 10, 20. Traffic exits here, traffic exits here. All you need to make sure that they belong to the same subnet. So that is all about the access ports and the VLAN membership that we can configure onto that particular. We did talk about the access ports in the last class. We saw a few situations where the users in VLAN 10 can communicate with the user in VLAN 20 as well. Access ports, again, access ports are those ports that are part of one particular VLAN. So if I put this port in VLAN 10, that port will only send and receive the data for VLAN 10. If I put this port in VLAN 20, that means that port will only send and receive the data for VLAN 20. Same goes here as well. So we can configure like VLANs on multiple switches as well. This is switch number 1, this is switch number 2. We can configure VLAN on switch number 1 and we can configure VLAN on switch number 2 as well. So here we have user in VLAN 10, here we have user in VLAN 10, here we have user in VLAN 20, here we have user in VLAN 20. So this switch is going to maintain the MAC address table. In the MAC address table, it is going to maintain that it has learned the particular MAC address in VLAN 10 and it has learned the particular MAC address in VLAN 20. And based on that, it can decide that the traffic either has to pass or it doesn't need to pass between the two devices. Now, the point is, if you have to connect two or more devices, that are in the same VLAN, such as in VLAN 10, VLAN 10, VLAN 20, VLAN 20, but on different switches. We can have like 2 switches, we can have like 3 switches as per our topology, for example, here. We have like VLAN 10 here, we have VLAN 10 here. So I want to ping actually from the device here to here. So if you want to connect, and then again, I have the user in VLAN 20 here, user in VLAN 20 here, user in VLAN 30, user in VLAN 30. So we have configured like multiple VLANs, and now I want to ping. I want the devices to be able to ping, trace, basically send and receive the data from VLAN 10 to VLAN 10, VLAN 20 to VLAN 20, VLAN 30 to VLAN 30, but on different switches. We have like different switches, we have multiple switches, and we want to exchange the data between those switches actually. So how can we achieve that? How can we allow the traffic from the VLAN in between the switches? So it says that switch maintains the MAC address table. In the MAC address table, it is going to maintain the VLAN information. So like the switch has learned that this particular MAC address is connected on VLAN 1. This particular MAC address is connected on VLAN 2. This particular MAC address is connected on VLAN 1. This particular MAC address is connected on VLAN 2. So the switch knows, for the switch, it is easier to determine whether to send the traffic when it is received on a certain port. So when the traffic is received onto this port, FA0x3, switch can take a look at the destination MAC address. If the destination MAC address belongs to the same VLAN, then the traffic is allowed to pass. But if the destination MAC address does not belong to the same VLAN, the traffic is not allowed to go through, right? So basic switch operation, basic switch, based on the basic switch operation, the traffic can go from a device to other device, or traffic cannot go from one device to the device based on what configurations you have done here regarding VLAN. Remember that VLAN we use to more like segment, to perform the segmentation in the network at the layer 2. Like at the layer 2, I'm configuring a boundary at layer 2. I'm creating a boundary at layer 2, which is going to control what two devices can communicate and what two devices cannot communicate to each other, right? But when we want to actually switch the traffic in between multiple switches, like we have user in VLAN 1, we have user in VLAN 1, we have user in VLAN 2, we have user in VLAN 2, and I want them to talk to each other in between the switches. In between the switches, what we need to do now, what we need to configure now, either we can configure multiple links, such as like this link in VLAN 10, this link is VLAN 20. So this port actually here belongs to VLAN 10, this port here belongs to VLAN 10, this port here belongs to VLAN 20, this port here belongs to VLAN 20. So the traffic will arrive from VLAN 10 and it can exit out of the interface in VLAN 10, will be received onto this port. This port belongs to VLAN 10, so the traffic can be sent towards the VLAN 10 user on the other switch. Same, when the traffic, for example, arrives onto this particular port, this port belongs to VLAN 20. So the traffic can exit from the port in VLAN 20, will be received onto the other end. This port also is an access port, belongs to VLAN 20. So the traffic can actually exit towards the VLAN 20 devices. So VLAN 10 to VLAN 10, VLAN 20 to VLAN 20, communication will happen accordingly without any problem, without any issue. The communication is going to happen. So we can connect multiple links. We can have multiple links between the switches. We can have multiple links between the switches, one for each VLAN. One for each VLAN. Like we can have like this link to forward the traffic for VLAN 10. We have this link to forward the traffic for VLAN 20. So VLAN 10 to 10 communication and VLAN 20 to 20 communication can happen. But this technique is not very useful. Why? Because let's say, for example, it is okay. We can configure it, but it is not very feasible. It is possible, but it's not very feasible solution. Why? Because like if you have users in multiple, like let's say 5 VLANs are here, 5 VLANs are here, and you want to send the traffic between those 5 VLANs, then you have to connect like 5 cables, like here, 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 here. We have to connect like 5 cables here. So this is a solution, but it's not a very feasible one. It's not a good solution from the design point of view, from the deployment point of view. Having a dedicated cable to carry the traffic for a particular VLAN is not a very feasible solution. And that is where our next operational port comes into the picture. Trunk port. Instead of configuring like one dedicated link for a VLAN, instead of configuring like instead of connecting multiple links, connecting like one for dedicated VLAN, what we can do actually, we can configure these things called trunk ports. We can configure like instead of doing this, we can connect one single cable here. We can connect one single cable here. This is one cable. This is just one cable between the switches. And the same cable is going to carry the data for VLAN 10. Same cable is going to carry the data for VLAN 20, 30, and 40, and basically rest of them. So we can use a single link, and that link will carry the data for multiple VLAN, which is going to be like possible and most feasible solution, most okay solution in our deployment. I want this link to carry the traffic for VLAN 10, VLAN 20, VLAN 30, VLAN 40, basically all the VLANs. So that can be done by connecting only one link and configuring that link as something called a trunk link, or configuring that port as something called trunk port. So trunk ports are those ports that carry the data for multiple VLAN. Trunk ports are those ports that are used to carry the data for multiple VLAN. Right? Trunk ports are those ports that are used to carry the data for multiple VLANs. So trunk ports can carry the data for more than one VLAN, all by default from one switch to other switch, and the data is still delivered in the same VLAN. Just because you have configured this link as a trunk link, it doesn't mean that the traffic will go from VLAN 10 to VLAN 20. The traffic will go from VLAN 10 to VLAN 20. No, the traffic will still go from VLAN 10 to 10, and the traffic will still go from VLAN 20 to 20. The communication will happen in the same VLAN only. The communication will happen in the same VLAN only. So trunk ports can carry the data for more than one VLAN from one switch to another switch, and data is still delivered in the same VLAN. How that happens actually? How the data that is sent, how the data that passes from the trunk link is delivered in the same actually VLAN? How that happens actually? So that happens with the help of this concept of VLAN tagging. Whenever the data passes out of a trunk link, the data is going to be tagged. Remember that the data will always be tagged when the data passes via trunk link. Apart from a few exceptions that are different thing, but when the data passes from out of the trunk link, the data is going to be tagged. So switch port receives the data. Switch port receives the data in VLAN 1. Switch port receives the data in VLAN 2. This port is configured in VLAN 2. So when the traffic is passed from this trunk link, if the traffic belongs to VLAN 1 tag will be added. If the traffic belongs to VLAN 2 tag will be added. Tag is used to identify, tag that we have here, tag is used to identify that the data belongs to which VLAN actually. So this switch is before sending the data out of the trunk link. This switch is basically sending some sort of it is adding some sort of hint that the data that I'm sending, it belongs to VLAN 1, or the data belongs to VLAN 2, 3, or whatever. So the data belongs to which particular VLAN, that indication, that hint is added in the data itself. And that hint, that addition is what we refer to as the VLAN tag. VLAN tagging is done. VLAN tagging is used to basically configure. VLAN tagging is done so that the switches know that the data belongs to which particular VLAN. So whenever the data exits out of the trunk link, the data is always going to be tagged with a particular VLAN. So when the data arrives on here, passes out of this interface, it is going to be tagged with VLAN 1. When the data arrives here, passes out of the trunk link, the data is going to be tagged with the VLAN number 2. And that is how the neighboring switch, once the neighboring switch receives that tagged traffic, the neighboring switch is going to understand based on that tag if the data belongs to VLAN 1 or if the data belongs to VLAN 2. And when it passes the data to the user in VLAN 1, it will remove that tag. When it passes the data to the user in VLAN 2, it is going to remove the tag. Tagging is never done on the access ports. So when the data is passed out of this port, it is not going to be tagged. Tag is going to be removed actually. Tag is going to be removed. Right? So frames sent out of the trunk port, they are tagged. VLAN ID is added as an identification tag for the data received on the port and exiting out of the trunk port. So the the user has sent the data is received onto this port belongs to VLAN 10. So when the data is passed, either you can pass the data out of the port in VLAN 10 untagged, but if you are passing the data out of the trunk link, the tag has to be added. Tag 10 is going to be added, and that is how the neighboring device will come to know. That the data belongs to which VLAN. It will read that tag, and based on that tag, it is going to pass the data towards the other device. This process, like when the traffic is received onto the switch port and traffic exits out of the trunk port, some extra information will be added. That extra information is going to be in the format of VLAN tag. So that process, that addition of that extra information is what we refer to as trunk encapsulation. Trunk encapsulation is a process of adding some extra information on the data that exits out of the particular trunk link, right? And also remember, when the data is forwarded out of the access port, that tag information is automatically removed. Tagging is always done on the trunk link. Tagging is not done on the access port. Tagging is always done on the trunk link. Tagging is not done on the access ports. No, not the outgoing port actually. So if you take a look at the MAC address table, the question is that in the CAM table, in the MAC address table, a VLAN tag field is also there along with the MAC address and the outgoing port. That is going to be there. Yes. So like if you check the MAC address table of the switch number 1, let's say we go to the switch number 1, and let's say we check the MAC address table by the command show MAC address table. If I check the MAC address table, you can see the switch has learned different MAC addresses, and you can see the VLAN number, VLAN 1, VLAN 1, VLAN 1, 1, 1, 1, it has learned. So when this switch receives the data, in this port belongs to VLAN 10. When the switch receives the data and it sends the data out of the trunk link, tag is going to be added. The switch will receive a tagged traffic. And once it maintains the MAC address table, it is going to maintain that MAC address A belongs to VLAN 10. That VLAN information is going to be maintained on here, on the trunk link, on the receiving side as well. So yes, MAC address table will include the VLAN information along with the exit interface and the MAC address information here. Now, who is going to do the trunking? Like, do we need to add this tag manually? Are we going to add this tag information when the data exits out of this particular interface? Are we going to add the tag manually? Are we going to do that manually? No, we're not going to do that manually. For that, we have the protocols as well. We just have to configure this port as the trunk port, and we have to tell this port to use one of the following protocol to perform the tagging, trunking. We have to tell this port to use the following protocol, either ISL or something called .1Q. I'm going to tell the switch port to use either inter-switch link or the .1Q protocol to perform the tagging. Right? So here, the tagging is done automatically. We don't need to do the tagging manually by the switch on the trunk port by using either of these trunk encapsulation protocol, Cisco proprietary protocol inter-switch link, and IEEE standard protocol, open standard protocol .1Q. Now, just for your information, what is the difference in between these two? Try to find out the difference in between these two. If you know, it's very good, but if you don't know, try to find out the difference between these two. Is there any difference in between these two? 802.1Q, small q, and capital Q. Try to find out the difference between these two. Which one we are talking about? We are talking about 802.1Q, small q. I have seen in interviews here, at least in India, in interview they ask this kind of question like, okay, what is the difference in between .1Q and .1Q? In a few places you will find a little bit difference, but in most of the cases you will find that these two are the same things. In fact, I will just in a moment I will show you. And you will see that there is no difference, but some people consider that these two are different things. Some people consider that these two are different things. And I'm not saying that they are wrong, but when we do configurations on the devices and all, you will notice that actually there is, actually no difference. But anyway, try to find out the difference between these two meanwhile. No. Q is also like a way of performing trunk encapsulation. That is also the same thing. The difference that I want to know is in between 802.1 small q and 802.1 capital Q. Anyway, so there are two protocols that we can use to perform trunk encapsulation, tagging of the data when the data exits out of the particular trunk link. One is called Cisco ISL and one is called 802.1Q. Now, if your device supports both, of the protocol, then you have to define which protocol you want to use. You have to tell the switch port to use either .1Q or ISL. If your device supports both of the trunk encapsulation protocol, .1Q and ISL, then you have to tell this particular switch port to use this one or this one. You have to do it, and then you will be able to configure that port as a trunk port. Otherwise, you will not. If your switch port supports both the trunk encapsulation protocol and you have not told this switch to use like ISL or .1Q, you cannot configure it as a trunk. It will just throw you a warning. It will just throw you some sort of error. But in modern day switch platforms, you will notice that ISL, Cisco proprietary ISL, is not even there. Like ISL, they don't recommend using it, and they also do not use this ISL trunk encapsulation technique nowadays. Right, so we'll talk about both of them a little bit. We'll talk about Cisco ISL, we'll talk about .1Q. However, we have to focus on this one. Now, trunk ports can learn more than one MAC address, of course. Like if you talk about the trunk links, of course, they will learn more than one MAC address. This is the trunk link. This is the trunk link. When you send the traffic, it will learn the source MAC address. When you send the traffic, it will learn the source MAC address. When you receive the data from here, you will learn the source MAC address. Here, you will learn the source MAC address. So a trunk link, a trunk port can learn multiple MAC addresses. We have already covered this. We have already talked about this. We have already talked about this. That we have already talked about this. That a switch port can learn multiple MAC addresses at the same time. So that could be that is one of the conditions in the trunk link, that if it is a trunk link, you will notice that these links can learn more than one MAC address at the same time, because the traffic is allowed from all the VLANs on here. Right? So a port can learn more than one MAC address. A port can learn more than one MAC address. A port can learn more than one MAC address, and based on that, like if it is a trunk link, you will notice that trunk link particularly will learn more than one MAC address at the same time. It makes sense. Like when we send the traffic from here, it will learn that MAC address. When we send the traffic from here, it will learn that MAC address. So that is a possibility. Yes. Let me know.
Sir, actually, both the switch are configured with the trunk link nut. So at that time, how much MAC address it can learn? Is there any capacity?
That is actually dependent on the capacity of the particular switch. So like if the switch can learn like 6,000, 8,000 MAC address, all those MAC addresses can be learned here. That is based on the capacity of the switch. Some switches can learn like 32, 33,000 of MAC addresses. So those it can learn there. So until you have put some limit on that port, it can learn like more than one MAC address based on the capacity of the switch.
Okay. Yes.
This thing actually we have covered in our previous classes. So for more detail, you can cover from the previous recordings, right? So there we have talked about like, okay, how many MAC addresses a switch port can learn.
Yeah. Okay, sir. Yeah. Thank you, sir.
All right. So a trunk port can learn more than one MAC addresses at the same time. Now, just because you have configured a port to operate as a trunk port, it does not mean that the port is not going to have any VLAN membership. Remember that access VLANs on trunk port still exist, but the port will not forward the data for that specific VLAN only. It will forward the data for all VLAN. What do we mean by this? We mean that let's say this port belonged to VLAN 99, and we change the operational mode of this port from the access to trunk. That means this port has become trunk port, and it will forward the traffic for all the VLANs. But that port still belongs to the access VLAN 99. That means if you remove the trunk configurations from that port, it will fall back to the same VLAN which was configured on there earlier. So just because, like, let's say, let me show you that quickly. Remember that in the last class, what we did on the switch number 1 interface Ethernet 0x0, we configured the VLAN membership as 10. Now, if I go on the Ethernet 0x0, if I use the command switch port mode trunk, it will convert that port. It will change the operational mode of that port from access to trunk. But if I hit enter, I might get an error. If I hit enter and it says command rejected, it says that your command was not accepted. It says that your command got rejected. Why? Because an interface whose trunk encapsulation mode is configured to auto cannot be configured to the trunk mode. If you get this kind of error, you must understand. You must understand that on your switch, you have like both the trunk encapsulation protocols available, and you did not define you are going to use which protocol actually. You have not configured the switch to use either .1Q or ISL. So switch is not sure if it has to configure that port as a trunk port, it is not sure that the tagging will be done either with the ISL or .1Q. Right? So it says command rejected. It says that the command that you configured, that the command you tried to configure, that command was actually rejected. So it did not accept that command. Switch did not accept that command. Right? Okay. So what we need to do here, we need to configure, we need to define what trunk encapsulation we want to configure. First, we need to configure, what trunk encapsulation protocol we want to make it trunk. That is fine. We want to configure that particular port as a trunk port. Completely fine, completely okay. But first, you have to define that what trunk encapsulation you actually need to configure. So I'm going to say switch port trunk encapsulation, and you have to configure .1Q or ISL. By default, it is neither .1Q nor ISL. By default, it is neither .1Q nor ISL. By default, trunk encapsulation protocol is negotiated with the help of DTP, dynamic trunking protocol. DTP is not only responsible to negotiate. DTP is not only responsible to negotiate the trunk, but is also responsible to negotiate trunk encapsulation protocol. So negotiate, that means the device will negotiate for the trunking, and the trunk negotiation will happen, and then it will choose either .1Q or ISL. But since I have to configure the trunk manually, I'm not going to use the DTP. I have to define either I'm going to use .1Q or I'm going to use ISL. Once we define that, then only I'm going to configure the mode. Then only I will be able to configure the mode to trunk. So first you have to configure the protocol, then you have to define the mode at trunk. So now you check, just because you configured the link as a trunk link doesn't mean that your VLAN membership is gone. It doesn't mean, like, show interface each 0 by 0 switch port. If you do that, you can still see that this particular port is operating in the trunk mode, and how the administrator has configured the port to operate in the trunk mode manually. Administrative mode is static trunk. That means we as an administrator have statically configured the port to operate as the trunk port, and as a result, the port is operating as the trunk port. What protocol we are using? Protocol is not negotiated. Protocol administratively is configured as .1Q, and the operational mode is .1Q. Even though we have configured that port as the trunk port, we can still see DTP is on. Trunk negotiation is still on. So if you configure, for example, if you configure this port as the trunk port, let's say, for example, you configure a particular port as a trunk port, this port will still be enabled for DTP, so that the neighboring devices can negotiate for the trunk based on the same. So trunk negotiation, DTP is still on when the port is operating as the trunk port. And what is this? Just because the port is operating as the trunk port does not mean that your VLAN membership is not there. You can still see the VLAN membership is there. See, show interfaces, switch port, show interfaces, switch port. You can see, so interfaces, switch port, you can see that the switch port is enabled. The name is like Ethernet 0 by 0, switch port enabled, administrative mode, operational mode, trunk encapsulation, trunk negotiation, and right here it says that the access VLAN is still 10. So you will not see that here. You will not see that port here, because that port is now configured as a trunk port. So you will not see that here. Show interface trunk. If you use here, you will see that the port is configured for the trunk port manually. Trunk port manually. What protocol? .1Q. Status trunking. VLANs allowed active. These are all, like, all the VLANs are allowed on that trunk link, and these are the VLANs allowed and active. And VLANs in the spanning tree, forwarding state, and not prune. We'll talk about that later. But we can validate the trunks like that. So just because you have configured the switch port as a trunk port doesn't mean that the VLAN membership is gone. It is still there. So if I remove that command, if I say interface is 0x0, switch port mode access, since the port is configured as a trunk port, it will not forward the data for VLAN 10 only. It will forward the data for VLAN 10, 20, 30, 40. Since the port is configured as the trunk port, the data will be passed for all the VLANs. But when we change the mode back to the access, it will fall back to the same VLAN that we have configured on there, right? The VLAN membership was configured to VLAN 10. So this is now going to be, this will fall back like show VLAN brief. It will fall back to the VLAN 10. It will not fall back to VLAN 1 actually. That is what it says. Access VLAN on the trunk port still exists. Like if we have configured the port to operate as a trunk port, that's okay, that's fine. But the access VLAN will still be there onto that trunk port. However, since the port is operating as a trunk port, the port will forward the data for all the VLAN, not only for that specific VLAN. It's more like unused. If the port is no longer operating as a trunk port, it will fall back to the same access VLAN that was configured on that particular port earlier. Yes, Utpal.
Yeah, so can you please explain the third option, what we have there again? I didn't get actually that one. So switch port encapsulation .1Q or ISL. There's a third option you mentioned, correct? What exactly?
Third option means negotiate. Negotiate means like the switch port mode, like this trunk encapsulation protocol is going to be negotiated via protocol called DTP, dynamic trunking protocol. So there are two switches connected. If we want that the switches should form the trunking automatically, we can use this thing called DTP, dynamic trunking protocol, which is responsible to perform trunking between the switches automatically. And
so in that case, we don't have to mention .1Q or ISL.
No,
so
they
the
will
other
negotiate
side,
it.
remote switch. So the remote switch, whatever it is sending, like if the remote switch is supporting ISL, automatically the switch 1 will configure its trunk as ISL, correct?
Yes, definitely, yes. Yeah. So if you have configured here ISL, it will be ISL. If you have configured here .1Q, it will be .1Q. If it is negotiate on both the end, then they will negotiate on ISL.
Okay. And I have one more question regarding that. If you go to our lab diagram, I have like switch will learn multiple source MAC address, correct?
Yes.
So if you go back to the diagram, I just want to tell about. So suppose here is a switch, correct? Like on a switch 4.
Okay.
Switch 4 until it's communicate with some host in switch 1, the switch 1 will not able to learn any other MAC address, correct? Switch 4.
Like these MAC addresses will only be learned on, let's say, switch number 1, 2, and 3 only when the data is passed. Otherwise, like until you receive the data onto these ports from some specific source MAC addresses, you will not be able to learn about them.
Okay.
That is true. That is correct.
Yeah. Okay, thank you.
All right. DTP is used for negotiation. DTP is actually used for trunk negotiation. We will study about DTP in more detail later on. So DTP, like if you don't want to choose the trunking manually, configure the trunking manually, we have the option to go for DTP, dynamic trunking protocol. And in DTP, trunk will be formed automatically based on the DTP configuration, and trunk encapsulation protocol will be chosen automatically based on the DTP configurations. Yes, Pulkesh.
सर लाइक कभी कुछ राउटर्स में L2 पोर्ट्स भी आते हैं, तो वो पोर्ट्स पे भी सेम फीचर्स होगा जो
exactly if you have a module on that you can connect onto the router, if you have a module that you can connect onto the router, and that module is a switching module, there you can have the same set of configurations. Yes.
Okay. And one more thing, sir, like आपने जो previous slide पे बताया था, like between two switches we have configured two links, one for VLAN 1 and one for VLAN 2. So अभी मैं अगर ये दोनों को trunk में configure करता हूँ, तो इसको हम लोग fallback mechanism configure कर सकते हैं अगर एक link down जाएगा तो?
No. If you configure like this like let's say if this is a dedicated link, then it's okay. Then they will follow the traffic respectively. That is fine. But if you configure like both link as a trunk link, then the STP will run and one of the port will be blocked. So you can change the parameter of the STP to make sure that both the links are up, or you can configure like ether channel bundling. But there is no like more like that fallback mechanism, that active standby mechanism is automatically there with the help of the STP, right? Because in STP anyway, the port is going to be blocked. So all the data will pass from this link. And if this link goes down, then the data will pass from this link actually. So it's more like automatic.
Okay, sir.
Yeah, actually, yeah, we can do that, Anurag. We can definitely, like, if the port is configured as an access port, it's recommended to configure, like, we will configure a VLAN membership on there. But if the port is operating as a trunk port, of course, like we might want to remove the VLAN configurations from that particular port, definitely. Right. So, like this was just for your information that even if you have configured the port as a trunk port, whatever VLAN membership you configured earlier, it will remain there until you remove it. If you don't remove it, that VLAN membership will still be there. And if you change the mode to again access, the port will fall back to the same VLAN that it is configured. So this point makes now sense that access VLANs on the trunk port still exist. Access VLAN on the trunk port still exists. But the trunk port will not forward the data for that specific VLAN. It will forward the data for all the VLAN. If the port is no longer operating as a trunk, it will fall back to its same access VLAN where that was configured onto the port earlier. So if the port was configured in VLAN 20 and you converted that port, if you change that port as a trunk port, if you configure the port as a trunk port, in that case, you will notice that the switch port will start forwarding data for all the VLANs, not only for this. But if you change the port back to access, it will now start forwarding the data for VLAN 20 because that is what is configured onto that particular switch port. It's not like it will fall back to the VLAN 1. Right? So trunk ports we can configure between the switches so that we can forward the data for more than one VLAN at the same time, like VLAN 1, VLAN 2, VLAN 3 at the same time. Yes, trunk port looks like it is part of all the VLAN. Yes, that is also one thing. If you take a look at here, if you use the command like show interface trunk, you can see that by default, all the VLANs are allowed onto that trunk link. So it looks like that the trunk port belongs to all the VLAN. Because actually, the traffic is being passed for all the VLANs out of that particular trunk link. Now the protocol, ISL, inter-switch link. Cisco proprietary trunking protocol, which encapsulates the entire frame with 30 bytes of extra information, which is a lot more overhead as compared to .1Q. So the protocol that we have for trunk encapsulation, this is called Cisco inter-switch link, Cisco ISL. So this is your Ethernet frame. This is your Ethernet frame. This Ethernet frame is having like, Ethernet header, Ethernet trailer, data, and everything. This is your complete data. This is complete data. This is complete Ethernet frame. ISL is going to add a 26 byte long header and 4 byte long trailer. 30 bytes of extra information it is going to add. 30 bytes of extra information it is going to add. And in the header, it is going to add this much amount of information. In the trailer, it will be like CRC, cyclic redundancy check for error detection. So in the header, it will add these fields. No need to worry about it. No one uses ISL. But ISL, Cisco. So ISL was a Cisco proprietary protocol to perform trunking. ISL, inter-switch link, was a Cisco proprietary protocol to perform trunk encapsulation. But the problem with ISL was that it adds way too much overhead onto the frame. It adds 30 bytes of extra information, 26 byte long header, 4 byte long trailer on every frame. So when the traffic is being sent out of the trunk link, 30 bytes of extra information will be added. When the traffic is received on the other side, that 30 byte of extra information has to be processed and removed. So it is comparatively a lot more overhead as the .1Q protocol. So because of this overhead, companies, they are no longer using this ISL protocol. They went ahead with the .1Q protocol. .1Q protocol became more like a standard protocol to perform trunking in a modern day network. Original ISL specification supported only 1024 VLAN, but later a revision to the protocol allowed all the 4096 VLANs, like it happens for the .1Q. So originally ISL supported only 1024 VLAN, and that is why, let me show you one thing. That is why if you create the VLAN, if you try to create the VLAN, you see this. What is this? This is a Cisco Catalyst switch, and on the Cisco Catalyst switch, we have ISL inter-switch link as the trunk encapsulation protocol available as well. So they call it ISL VLAN. They used to call it like ISL VLAN. So inter-switch VLAN, ISL VLAN ID. Do not get confused. Like if it says ISL VLAN, then it's not going to support dot. It's not like that. It is still going to support .1Q or anything. The point is, the main point is that earlier in the original implementation of the our ISL, only 1024 VLANs were supported. Only 1024 VLANs were supported. But later on, a revision was made to that ISL protocol, and then they started supporting like others. They started supporting like other as well. So modern day, if you still see, if you are able to still see ISL somewhere, maybe on some particular switch, you will see that that protocol actually supports like all the VLANs. Like it's not like it will only support only that VLAN. It will support like all the VLANs, right? Now, it is not compatible with .1Q. What do we mean by this? We mean that if we have configured ISL to be trunk protocol, trunk encapsulation protocol, it has to be configured on both the sides. Like here, ISL, then here also ISL. Here .1Q, here also .1Q. There is no like what we say interoperability, compatibility between .1Q and ISL. So like you have to configure like either both the end as ISL trunk, or you have to configure both the end as .1Q trunk for the trunking to happen properly. And think about it. If the ISL is sending the frames, it is going to encapsulate it with total 30 bytes of extra information, including these all fields, which is not understandable, which is not understood by the .1Q protocol, because it only adds 4 bytes of extra information. So compatibility is not there between .1Q and ISL. So because of trunk encapsulation protocol mismatch, your traffic might get lost as well. So that is also one point to consider when you are troubleshooting the basic connectivity on the switches. Okay. It is not an industry standard protocol, and it is no longer used in a real-time environment. Most of the organizations, they have adopted using the .1Q protocol actually. And if I show you, if I'm sure, this is again a Catalyst 9300 series switch that we have in our lab environment, right? This is a physical switch, Catalyst 9300 series switch, running on iOS XE version 17.3. Oh, sorry, not 16 point something. 16.12. This is running on iOS XE 16.12. If I go like interface gigabit 1 by 0 by 1, switch port trunk encapsulation command is not even there, right? So you actually do not have both the trunk encapsulation protocol in the modern day switches. You only have one trunk encapsulation protocol in the modern day switches, and that is .1Q. So in older switch platforms such as 3750 or 3536, you might still see both the protocols available, but in the latest operating systems, in the latest iOSs, you will notice that they have removed ISL from their configuration. Even Cisco, they don't support ISL anymore, right? Okay. Forget about this for the moment. Forget about it. So ISL is one of the protocol that we use to perform trunking between the switches. The other protocol that we can use to perform trunking between the switches is called .1Q. It is called 802.1Q, or generally referred to as .1Q. It is an open standard protocol right? It adds 4 bytes of extra information inside existing Ethernet header. So this was your data link layer header. This was like data and trailer. This was header. So in the header itself, it is going to add .1q header. Internal tagging, it is going to perform. Smart tagging, it is going to perform. It is just going to add a 4 byte long extra information in between this source MAC address and the type field. It is going to add a 4 byte long extra information, and that's 4 byte long extra information that is added. It is added inside the Ethernet header itself. So it adds 4 bytes of extra information inside the existing Ethernet header. That is why it is also called internal tagging or smart tagging. It is not compatible with ISL, and it supports all the 4094 VLAN. Since it adds very less extra information, it is used in industries for the trunking nowadays. So this is like 82.3 Ethernet header, Ethernet frame, and this is the .1q frame. In the .1q frame, you will have that extra information. Now, what is this .1q header? What content is there inside this .1q header? The content inside the .1q header is like this. This is the .1q header. This .1q header is going to be 4 byte. 4 byte means 32 bits. First 16 bits are called TPID, tag protocol identifier, which is going to be 8100 to mark the frame as .1q frame. To mark the frame that it is a .1q frame, this TPID, tag protocol identifier, is going to be 0x8100. First 16 bits will be TPID. First 16 bits will be called TPID, tag protocol identifier, and these first 16 bits will be 0x8100. The last 16 bits that we have here, they are going to be divided like that: 3 bit plus 1 bit plus 12 bits. So 3 bits are called PCP, priority code point. 1 bit is called discard eligibility indicator, drop eligibility indicator, discard eligibility indicator, and so PCP, DEI, and then 12 bits is VID, stands for VLAN ID. And this whole is what we call TCI, tag control information. So first 16 bits are called TPID, tag protocol identifier, which will be 0x8100 to mark the frame as .1q tagged frame. And the last 16 bits are called TCI, tag control information. In this last 16 bits, we will have fields such as PCP, 3-bit fields such as PCP, 1-bit fields such as DEI. PCP stands for priority code point, DEI stands for drop eligibility indicator, and VID stands for VLAN ID. These are used in more like quality of service, especially this field. It is used to perform marking in quality of service at layer 2. So marking at layer 2 is done on the trunk links with the help of or by changing the PCP bits on the frame. So when the frame is tagged and sent out of the trunk link, I can define the priority of that particular frame by changing the bits in this PCP field. Right? You can mark the frame for better priority, better prioritization using this PCP field. Drop eligibility indicator or discard eligibility indicator. This field is called, this field is used to mark the drop probability, like if the frame is going to be dropped in case of congestion or not. So this is 1-bit field set to 0 or 1 to mark the frame eligible or not eligible to be dropped in case of congestion. So these bits, these bits are actually more like, for these are called like class of service, like cause bits, like especially this is called 802.1 I think P class of service. So like these are used for quality of service, to perform quality of service on the frame. No need to worry about that. The field that we need to see is this field called VID, stands for VLAN ID. The .1q header will have first 16 bits, 16-bit field set to a value of 0x8100 in order to identify the frame as .1q tagged frame. This is called TPID, and the last 16 bits are called TCI. That field has subfields called PCP, priority code point, a 3-bit field which refers to IEEE 802.1p class of service and maps the frame priority level. We can define the priority of the frame by changing these 3 bits called PCP. Different PCP values can be used to prioritize different class of traffic. And DEI, 1-bit field, it is used to indicate the frame's eligibility to be dropped in presence of congestion. So if there is some congestion, can the frame be dropped or not? That is there, that is marked with the help of this theme called DEI. Earlier, this was called CFI. Earlier, in the older implementation, this was called CFI. CFI stands for canonical format indicator. Canonical format indicator. So, you know, when we used to have the technologies such as a token ring, FDDI, the way devices read the MAC address was different. In some technologies, like we read the MAC address from left to right. In some technologies, the MAC addresses are read from right to left, right? You know, so like the canonical format indicator was used to represent the format of the MAC address. Like, is it canonical? It is not. Is it not canonical? So there we had that field called CFI, canonical format indicator, to find out if the MAC address is canonical or non-canonical. Basically, are we going to read it from left to right or right to left? Since these things were being used in the technologies such as FDDI, token ring, and those networks. So since those technologies we do not use nowadays, switches do not support even those values, those things. So this CFI field was got rebranded, you know, it is going to be reused as a new field called DEI, drop eligibility indicator nowadays. So you don't need to worry about this. CFI field you will not see in a modern .enq header. And the last field is called VLAN ID. 12-bit field. It specifies like for what what VLAN that particular frame belongs to. The value 0 and the value 0 and 4095 is the result. Total we get 4096 tags. Total we get 4096 numbers to perform tagging, where the number 0 and 0 like 4095 is the result. 4095 is the result for implementation purpose, must not be configured or transmitted. And like you will notice the use case of the VLAN 4095 in you know virtualized environment such as ESXi. You know, when we talk about VMware and all those technologies, you will see that in there we can configure this thing called like port group and all. We can mark that particular port group with the VLAN number 4095. So, you know, in technologies such as VMware, like ESXi and the other, some of the technologies, you will notice the use case of the 4095. But in our switched environment, like in between the switches, you will notice that in our catalyst switches, you will notice that these FFFF, like this FFF, basically the 4095 is not going to be used actually. You know, we call that VGT, virtual guest tagging. So you will notice the use of this FFFF whenever you see the things such as VMware, virtualized environment, when we create the port groups and all. So there you will use this thing called this, like number 4095, and the number 0 is also result. The number 0 and FFF, they are result. Number like 4095 is result for implementation use, and it must not be configured or transmitted on the catalyst switches. So we cannot do that. And you can see the options, like if I say VLAN, what option we get to configure the VLAN? We get the options from 1 to 4094 only. So we cannot even configure VLAN 0 and 4095 on our catalyst switches. The number 0 indicates that the frame does not carry the VLAN ID. Maybe this is our traffic. This is, let's say, our voice traffic, right? Let's say this is our voice traffic that I am transmitting out of this particular interface, front interface. I do not want to tag it, but I want to define some sort of priority. I want to define some sort of, you know, priority onto that particular frame. So in this kind of situation, like the traffic that exits out of this particular trunk link will have the VLAN ID as 0x000, which is like VLAN number 0, and the appropriate priority value on here. So like the result value 000 indicates that the frame does not carry the VLAN ID. In this case, this tag specifies a priority, and that is referred to as the priority tag. Right, so number 0 and number F4095 is result. Number 0 is result to just mark the frame with an appropriate priority level and forward it towards the next switch without configuring any VLAN ID as a tag. Maybe for our voice video packets, I do not want to add any overhead on those packets, but I do want to actually perform the tag. I do want to actually define some priority level on the same. So that thing can be done with the help of the value 0, and F4095 is result for the implementation purpose. And number 1 is often result for network management. However, this is vendor specific. By default, all the switch ports belongs to VLAN 1 on Cisco Catalyst switches, and we can use VLAN 1 for the management purpose as well. We can configure the IP address in VLAN 1 on switches, and that IP I can use to perform management level task of that particular switch. We can change that management VLAN to something other as well. Not configured, but used automatically. We have not configured VLAN 0, right? But what we are doing, the IP phones, whatever traffic that they are transmitting, I'm going to use that traffic, and when I forward the traffic out of the trunk link, I'm going to prioritize it. I'm just going to add some priority to it, but I don't want to tag it. So when the traffic exits out of the trunk link, it will not be tagged, just the priority will be set. So we did not configure VLAN 0. It will be used automatically in this situation. Right? So this is the 4-byte long. This is the 4-byte long .1q header. Now, let's implement it. Let's, in our topology, let's implement trunking. So we want to configure trunking on, let's say, for example, a switch number like on in between, like Ethernet 0x2, 0x3. So I can say interface range Ethernet 0x2 and 3, switch port trunk encapsulation .1q, and switch port mode trunk. Right? And same command, what we had to do, same command, we have to go on switch number 5, and here also switch number 5, I'm going to configure all the links, interface range Ethernet 0x0 to 3, switch port trunk encapsulation .1q, switch port mode trunk. So all these interfaces I have configured as trunk interfaces, right? So these are all 0x0, 1, 2, 3. These all are trunk interfaces, and the trunk protocol that we are going to use is .1q. Unfortunately, like this software, like EVNG, we can configure ISL trunking, but it might not work as expected. It might not give you the appropriate result. You can configure the trunk encapsulation to be ISL as well, completely your choice. You can do some packet capture to find out the format and all, but I really doubt that you will be able to see anything. If not sure if they have added something in the new versions of these switches, but the old version, they do not behave properly when we configured ISL trunking in this EVNG scenario. So on switch number 5, I have configured the links as a trunk link. Same thing, I'm going to go on switch number 6 as well. Configure terminal, interface range Ethernet 0x0 to 3, switch port trunk encapsulation .1q, switch port mode. So same thing, I'm going to go on switch number 2. Here also, same command, interface range 0x2, 3, switch port trunk encapsulation .1q, switch port mode trunk. And I'm going to copy and paste this command on the rest of the switches as well, because eventually same thing I'm going to use here as well as here. So I'm using pure .1q based trunking, I'm not going to use ISL. So on switch number 1, switch number 2, switch number 3, switch number 4, switch number 5, which is our distribution layer switches, switch number 6, we have configured the .1q trunking. Now let's do the capture on this interface 0/2 right here. So I have started the packet capture onto that particular interface. A few messages are being sent. No need to worry about that. Right. So STP is running. So STP messages are being sent. No need to worry about that. Now let's go to this host machine. Do I have the IP? No. So this user here belongs to VLAN 10. If I go switch 1, do show run interface is 0/0. It belongs to VLAN 10. For VLAN 10, I am going to configure the IP address 192.168.10.1 and gateway 192.168.10.100. For VLAN 10 user, this is the IP I am going to configure. On switch number 2, do I have a user in VLAN 10? Yes, I do have a user in VLAN 10. So configure terminal, interface, Ethernet 0/0 here goes towards VLAN 10. So go to the host number 3 and configure the IP from the same range 192.168.10.2. Switch number 3, do we have a user in VLAN 10? No, we don't have a user in VLAN 10. Okay. Switch number 4, do we have the user in VLAN 10? Do show VLAN brief. Yes, we have the user in VLAN 10. So I will go here and configure it with the IP address 192.168.10.3. So I have configured 192.168.10 on VLAN 10. Similar to that, I'm going to configure 192.168.20 for the users in VLAN 20. So do show VLAN brief. This port goes towards VLAN 20. You can see that. So I'm going to go on host number 2 and I'm going to configure IP address from a different subnet. One VLAN, one broadcast domain, one network. So all the users in the same VLAN will have the IP from the same network. All the users in a different VLAN should have the IP from a different network, which I have configured. Do we have VLAN 20 somewhere else on system number 2? Yes, no, we don't have VLAN 20 on here. On system number 3, yes, we have VLAN 20 on here. So here is in VLAN 20. So it is going to be like 20, 20. Do we have the user in VLAN 20 on system number 4? No. Similar to that, we have user in VLAN 30. So on system number 2, we'll have a port going towards user in VLAN 30 here. So I will go on system number 4 and I'm going to configure the IP VLAN 30 here. So 30.100 and it is going to be 30.1. Similar to that, do we have the user in VLAN 30 somewhere else? System number 3, yes, on system number 3 as well. This user is there in VLAN 30. So I'm going to configure the IP in VLAN 30. System number 4, yes, on system number 4 also, we have the user in VLAN 30. So I'm going to configure the IP on there as well. So just, it doesn't get complex. What was the password? I don't remember. I forgot the password actually to unlock this lab. So what I was doing, I'm going to add the text here. VLAN 10, right? So, and I'm going to so this is in VLAN 10. This user is going to be in VLAN 10. Where is that? Oh. So here we have a user in VLAN 10. VLAN 10 Just wait, I will edit in a moment. So you have the idea that the user belongs to which particular VLAN, right? So this is VLAN 10, this is VLAN 20. So the user is in VLAN 10, the user is in VLAN 20, right? On system number 2, let's quickly go to system number 2. VLAN 10, that is correct, and this is in VLAN 30. So this is going to be in VLAN 30. System number 3, 20, 30. So this is going to be 20, and this is going to be 30. And on system number 4, quickly, it is 10, 30. So this is 10, and this is 30. So this is how we have configured the VLAN membership. This is how we have configured the VLAN membership. Now, if I ping, let's say I try to ping from host machine 1, I try to ping 192.168.10.2, and I try to ping 192.168.10.3, right? We should get the replies accordingly. So if not, then we will try to troubleshoot why it is not replying. As I can see that it says unreachable, unreachable. What could be the possible problem? Let's try to troubleshoot. So first thing first, check the IP. So I went on host machine 1. I use the command show IP. I can see that IP is configured. IP is configured here, 10.1. It's okay. IP is configured here. Let's move on to system number 1. Let's see if the switch is learning the MAC address on Ethernet 0x0 or not. Show MAC address table on interface Ethernet 0x0. So looks like yes, switch is learning the MAC address. Switch is learning the MAC address. That is correct. That is fine. So if the switch has learned this MAC address in VLAN 10, it should forward the traffic out of the trunk link towards the other devices. So do we have trunk? Show interface trunk. Yes, we do have trunk. Trunking is done based on .1 queue. Trunking is done based on .1 queue. So the traffic will now exit out of here and it will arrive on the distribution layer switch number 5. Let's go on switch number 5. Show interface trunk. We do have all the interfaces configured as trunk. We do have all the interfaces configured as trunk. We do have all the interfaces in up state. Everything is working fine, but still we're not able to ping. Why? This switch is learning the MAC address or not? Show MAC address table. Has this switch learned the MAC address or not? What MAC address? This MAC address. If the switch has learned this MAC address or not. So, no. Devinder, there might be some issue with the audio video. You can try to rejoin once. Might be the problem from the portal, from the browser actually. So you can try to rejoin once. So the point is, this switch has learned the MAC address. The switch must have forwarded. The switch must have forwarded the traffic out of this interface after tagging it with the VLAN 10. And just to show you that, I have done the packet capture. I have done the packet capture here. Here, we have done this packet capture as well. So at the moment, we are receiving all these. Actually, see here, I tried to ping 192.168. I tried to ping 192.168.10.2. I tried to ping 192.168.10.3. If this machine tries to ping 192.168.10.2, it first needs to know the MAC address of that device. For that, it has sent the ARP request, but it never got the ARP reply. Who has 10.2, 10.2, 10.2? Who has 10.3, 10.3, 10.3? It sent the ARP request, but this machine never got the ARP reply. Why is that? If I open this ARP request message, you will notice one thing. If I open this ARP request message, so this machine generates an ARP request, source MAC address, its own MAC address, destination MAC address, FFFFFF, broadcast MAC address. Packet arrives onto this particular interface. So it reads the source MAC address, maintains it in the MAC address table, then checks the destination MAC address. Destination MAC address is FFFFF. It decides to flood the frame out of all the interfaces in VLAN 10 and out of the trunk interface. When it forwards the frame out of the trunk interface, you will notice if you open this particular frame, some sort of tagging is done. This is not an Ethernet frame, it is a .1q frame. So you see data link layer header. In the data link layer header, we have that TPID, tag protocol identifier, as 0x8100, and the TCIE contains the VLAN ID as the tag in the decimal, in the binary format. This is the .1q tag that I was talking about, and just for your information, keep this in mind. Okay. Now, this neighboring switch receives that frame, basically that ARP request, receives onto this port, it should learn the source MAC address of that frame, but it did not learn the source MAC address of that frame. Why? Why has this switch not learned the MAC address of that particular frame? Because any suggestions, any guesses why? Because VLAN 10 does not exist onto this switch. Remember, in the last class, we did talk about that for end-to-end communication, the VLAN must exist on all the switches through the path. And unfortunately, on switch number 5 and 6, we did not configure the VLAN. That is why it did not actually learn the MAC address for that particular user. So we should configure VLAN 10.20.30 on here, and we should configure VLAN 10.20.30 on here. VLANs must exist. Even though there is no user in VLAN 10.20.30, doesn't matter. But if you have not configured the VLAN, those VLANs are not allowed onto the trunk. Means like they are not allowed into the trunk. Like VLANs are allowed onto the trunk, but they are not active in the domain. On this switch, we configured only two VLAN, VLAN 1 and VLAN 2. So only those two VLANs were allowed. So it can send and receive the traffic on Ethernet 0 by 0, 1, 2, and 3 only for those two VLAN 1 and 2. But now when we configure the trunk, you will notice that all the rest of the VLANs will be allowed as well. So, and of course, you have to wait for 30 seconds, because once we configure the VLAN, it will take 30 seconds for the ports to go into the forwarding state for that VLAN because of the protocol, spanning tree protocol. So you have to wait for additional 30 seconds. Once you have done waiting, now you go on host machine 1, try to ping 192.168.10.2, you are getting the reply, and try to ping 192.168.10.3, you are getting the reply. And if you take a look at the packet captures, if you take a look at these captures here, now you send the ARP request, you got the reply. You send the ARP request, it was broadcasted in the domain, and then you got the reply. Here, you got the reply. And of course, you should have also ICMP. If you filter ICMP, you send ICMP echo request, reply, request, reply, request, reply. Now the ping process is successful. VLAN ID is being used as the tag. So when the tagged traffic is received onto this particular switch port, it will read that tag, and based on tag, it will decide what it has to do with that particular frame. And same thing, if I do, let's say, if I go on host machine number 2, here, host machine number 2, if I say ping 192.168.20. Let's say, for example, 1, my own IP, 20.2, ICMP echo request, echo reply, after ARP request, ARP reply, and 20.3 if it exists. 20.3 if it exists. .3 does not exist. Only like there are two VLAN 20. So here and here only. So 20.1, 20.2. So you can see that as well, that when the traffic passed out of the trunk link, now when the traffic passed from the trunk link 20.1 to 20.2, you can notice that the tag number is 20. And based on that tag, the upstream switch is going to decide that the data belongs to which particular VLAN, and it will forward the data accordingly. So the VLANs were not present because of that data was not being sent actually. Same, you can go for like VLAN 30. For example, you can go on from host machine number 4, and from the host machine number 4, you can actually ping 192.168.30.1, 30.2, 30.3, same process, and everything will happen. ARP request, ARP reply, tag, ISMP echo request, echo reply, tag, and everything will happen, and you will get the replies accordingly. So this is how your tag looks like. This is how the data looks like when it is tagged with 802.1q. Yes, Utpal.
So actually, I missed that part. So you have configured the VLAN on that switch?
Yes.
To allow the traffic, or you just configure a trunk?
No, I configured the VLANs on here. Here, we configured VLAN 10.20.30, and I configured VLAN 10.20.30.
On that switch 5, correct?
Yes, 5 and 6 both.
Okay. So if you just only configure trunk, those will not carry until that.
No.
Okay.
No, that will not work. Like trunk is just to tag the traffic, but if the VLAN does not exist, like the traffic will be dropped. And that was happening actually earlier. So once we configured the VLAN, then the traffic is being passed accordingly.
Got it. Thank you.
All right. Now you can also do this. Let's say if I go on switch number 1, just for your information, configure terminal, interface, Ethernet 0x2, switch port, trunk, encapsulation, ISL, and you can go on switch number 5 as well. And here also you can configure the same, because trunk encapsulation must match. So on switch number 5, onto this link, switch port, trunk, encapsulation, ISL. I have configured ISL trunking on both the side. I have configured ISL trunking on both that side. So like here, I have configured ISL, and here I have configured switch port trunk encapsulation protocol as ISL. If I say do show interface trunk, you can notice that the trunk encapsulation onto that particular interface is now ISL. Now you can configure ISL like on the other links as well, such as here, just in case if you want, like interface 80x1, switch port, trunk, encapsulation, ISL. You can go to switch number 2, interface 80x2, switch port, trunk, encapsulation, ISL. So I configured ISL here, and I configured ISL here. Like on these two, I have configured ISL. Here it is .1q, here it is .1q. Basically, rest everything is .1q, but I have just configured ISL between these two. Let's see if the ping will be successful or not. If I go to host machine number 1 and I'm trying to ping 192.168.10.2, the ping is successful. If I try to ping 10.3, the ping is successful. Right? If I do the capture here, if I check the capture, I think close it. I'm not able to see anything in the capture actually. I'm not able to see anything in the capture. The problem is like everything is working fine. There's no problem with that. Everything is working fine. Everything is okay. There's no problem in that. Just that like ping and trace is working fine as well as usual. Like there's no difference in that. But the when we talk about like this configuration, when we talk about this configuration, you will notice that ISL will be responsible to forward the data exactly the same way as the .1q, and it will add the ISL header and trailer. But that information is actually not that ISL header and trailer addition is not captured by this packet tracers, this Wireshark tool. So that is why we are not able to see that. We are not able to see that capture in the capture. So everything is working fine. There's no problem with that. Everything is working fine. Just that capture we are not able to see. Right? We are just not able to see the capture. Everything else other than that is working just fine. So it doesn't matter what we have configured, like if you have configured ISL, if you have configured .1Q, it actually does not matter. The traffic will be passed exactly in the same way without any problem. You might not be able to do the capture. You might not be able to do the captures actually in this simulated environment such as EVNG. You might not be able to do the capture, but everything other than that, like it will just work as usual. And sometimes when we configure ISL, it doesn't even work actually. So I'm pretty much sure that the traffic that we are sending actually, it's not getting passed on to this link. I'm very much sure that the traffic is passing from this link actually. Because as I am aware with this EVNG software, like as much as I am aware of this EVNG software, this doesn't support ISL properly. So I am very much sure that the traffic is actually not passing via this link. The traffic is passing via this link, and I can try to prove it. That if I go, for example, on system number 1, if I go on system number 1, if I say like interface Ethernet 0x3 and I shut it down, I have shut down this interface. Right? I go on like system number 6 as well, and interface Ethernet 0x0, I shut down. I have shut down this interface. So this link is down. Now you have no other way. You have no other option. If you want to go from here to here, you have to go like that. If you want to go from here to, let's say, for example, here, you have to go like that. You have no other option actually. And now if I go on system host number 1, try to ping 192.168.10.2, it just does not work. 10.3, I did not do anything extra. I just changed the trunk encapsulation to ISL. That is the only thing that we have done. We have not done anything extra, and we are not able to see anything here, not in the capture. It just doesn't support it. It's not like it will not work. If you have in your environment, if in your environment you have both protocols supported, .1Q and ISL, it will work properly. Just in this simulated environment, it does not work. Right? So actually, switch port trunk encapsulation .1Q, I'm going to rechange it. I'm going to change it again to .1Q as usual, because I know that it doesn't work with ISL. It's not like it will not work in the real devices. It will just not work in this software. It just blocks the ports. This is how we can configure VLAN and trunk. We can also control what VLAN I want to pass from these interfaces. Let's say I do not want to pass interface range 0x2 and 3, switch port trunk allowed VLAN. I can control that I only want to allow VLAN 10 traffic. I do not want to allow VLAN 20 traffic. I can control, by default, all the VLANs are allowed, but I can control that I only want to allow VLAN 10 traffic. Do show interface trunk. You can see that only VLAN 10 is allowed and active. I can control that I want to allow 10, 20 both. So that I can do. Basically, you can control do show interface trunk with this command, switch port trunk allowed VLAN. We can control that what VLANs I want to allow onto that particular trunk link. Right? Something like that you can configure, like I want to allow VLAN 10, 20 to 30, then 111. So we can configure like what VLANs we want to allow onto the particular trunk link. Switch port trunk allowed VLAN command is there. Switch port trunk allowed VLAN command we can use to configure particular VLANs to be allowed on the trunk links. We can also say remove switch port trunk allowed VLAN, remove 25 VLAN from the allowed VLAN list. From the allowed VLAN list, remove number 25 VLAN. Now you see, to show interface trunk, you see that 25th number of VLAN is gone. I can say switch port trunk allowed VLAN add. Add means add this VLAN as well. In the existing list, add this VLAN as well. If you do not mention the add add keyword, if you just say like this accidentally, it will remove all the VLANs from here and it will just allow the VLAN this one. So be very careful. It will cause a lot of issues in your production environment if you miss these keywords such as add, remove, and it has happened. It has happened with a lot of candidates that I know. It has happened in the production environment. So ideally, always take out a notepad, whatever configuration you need to do, just do it there, cross-verify it, and then paste it there. So add keyword, remove keyword, those commands like, switch port, trunk, allowed VLAN, like this keyword, add, this keyword, remove. If you miss these keywords while adding or removing the VLAN onto the trunk link, it will cause a lot of problems. Except for the VLAN 20, everything else is allowed. Except for VLAN 20, all except this VLAN. Except for VLAN 20, everything is allowed. So we can configure, we can control what VLAN is actually allowed onto the trunk link, but not as per our requirement. We should explicitly configure the VLANs that we want to allow out of trunk link. Since I know that I have the user in VLAN 1020 only, I should always switch port trunk allowed VLAN. I should say like VLAN 10 and 20 is only VLAN that I want to allow out of there. Just more like for a security reason. So that, if the user in VLAN 30 tries to communicate with the users in VLAN 30, it's just not allowed. We should make sure that as well. So we can control what VLANs we want to allow, we want to remove onto the particular trunk link as well. And that is pretty much all that you need to know from the trunk link point of view. Well, it means like trunk configuration point of view. There are more things, but this is like how you can configure the trunk, how you can configure the trunk encapsulation protocol, and how can you control what VLANs we want to allow or not allow on the trunk link. Now, what if a trunk link receives a frame and the frame doesn't has a tag? Untagged. What if the switch port receives a frame, that port is a trunk port, but the port is not having any tag? Based on what trunk encapsulation protocol we have configured, switch will behave differently. Right? So if the trunk port receives a frame that doesn't has any tag onto it, and the trunk encapsulation protocol is ISL, it is just going to drop it. ISL does not support untagged frame. ISL expects that the frames that I will receive will have the VLAN tag in it. ISL doesn't support untagged frame. If the traffic arrives on here and the traffic has to be sent out of this trunk link, and this trunk link is this trunk port is an ISL trunk, in that case, the data is going to be encapsulated with the ISL header, ISL trailer, and then the data will be sent towards the neighboring device. So it is expected that I will receive the data with VLAN tag. It is expected that I will receive the data with VLAN tag. So ISL does not expect the data without the tag. So if on the ISL trunk you receive the data without the tag, the data is just going to be dropped. But in .1q can deal with it. In .1q, actually, 802.1q, .1q, if the trunk link receives an untagged frame, there is a special purpose VLAN. There is a special VLAN on every .1q trunk On every .1q trunk, there is one VLAN to handle the untagged frame. Not talking about that access VLAN, no. On every .1q trunk, there is a VLAN that is supposed to, that job is to handle all the untagged frame. So if I receive the untagged frame, I will consider that the data belongs to that particular VLAN. And I will try to forward the data to the users in that VLAN, or forward the data after adding the tag of that particular VLAN. So if the .1q trunk receives untagged frame, if the .1q trunk receives untagged frame, the untagged frame belongs to a VLAN configured onto that trunk. That VLAN is what we call as the native VLAN. Native VLAN concept is not there in ISL. Native VLAN concept is not there in the ISL. There's no concept of the native VLAN in ISL to support untagged frame, because the traffic from the VLAN is completely encapsulated with 26 byte long header and the trailer. So there is no such concept of native VLAN in ISL. So if the ISL trunk receives untagged frame, it will just drop it. It will not forward it. But in .1q, we have a special purpose VLAN called native VLAN to support the untagged frames. .1q uses the concept of native VLAN. By default, the native VLAN is 1 that can be changed as per the requirement. So here we have native VLAN as 1. Here we have by default native VLAN as 1. So if I receive the untagged frame on here, the frame will belong to the native VLAN, which is by default 1. So the traffic will be forwarded to the users in VLAN 1. If the traffic is not having any tag, it will be assumed that the data belongs to native VLAN. Whatever VLAN is configured as the native VLAN, data will forward there. So to support the untagged frame, .1q uses the concept of the native VLAN. Default native VLAN is 1, but it can be changed as per the requirement. So if the frame is received on the trunk port and the frame is not having any tag, it will belong to the native VLAN configured onto that trunk port. And we can configure maximum 1 VLAN as the native VLAN per trunk basis. So let's say I configure VLAN 11 or VLAN 22 as the native VLAN. And I receive the data. Data is not having any tag. Data is not having any tag. Untagged. I have received the data that is not having any tag to it. Switch will see that on trunk link, I have received untagged frame. What is the native VLAN configured onto that trunk link? 22. Data will be forwarded towards the user in 22 VLAN. And also, let's say I have configured the VLAN 22 as native VLAN. So when the data arrives from the LAN side onto this port, the port belongs to VLAN 22. When the data is forwarded out of that trunk port, the data is not going to be tagged as well. So untagged frame belongs to native VLAN. If the data belongs to native VLAN, data will not be tagged as well. Both the conditions are there. So if I receive the data onto the port, data belongs to VLAN 22. Data is forwarded out of the trunk link. Data is not going to be tagged if the native VLAN is same as the access VLAN. Here, we configured that on this trunk, we configured the native VLAN as 22. So when the data is passed out of that trunk link, if the data belongs to VLAN 22, it is not going to be tagged. And when the untagged frame is received, the data will belong to the native VLAN. So we must configure the same VLAN as the native VLAN if we want to pass the data towards the VLAN 22 user. Native VLAN must match. Native VLAN must match. If the native VLAN doesn't match, there will be a problem. Again, repeating. Onto this trunk link, I have configured VLAN 33 as the native VLAN. Data arrives onto this port. Data belongs to VLAN 11. Data will be tagged and sent. Traffic arrives onto this port. Data belongs to VLAN 22. Data will be tagged and sent. But when the traffic arrives onto this particular port, this port belongs to VLAN 33. When the data is passed out of the trunk link, since the native VLAN is the same, data is not going to be untagged. And when the data is received onto this particular port, that untagged frame will belong to the native VLAN. What is the native VLAN configured here as well? VLAN 33 is also configured as the native VLAN. So the data will go to the VLAN 33 user. So to support the untagged frame, we have this concept of the native VLAN. Default native VLAN, and default native VLAN is 1 actually, but you can change it. So native VLAN is there to support untagged frame. So if the frame is untagged, it will belong to the native VLAN first of all. And if the data belongs to the native VLAN, data will not be tagged while being sent out of the trunk link as well. Now, what is the use of this native VLAN? Like, why do we use this native VLAN concept? For what type of traffic we actually do not want the switches to add a tag? This is the data traffic. Can be tagged, no problem. But there are some types of traffic in our production environment for which I do not want to perform tagging. Such as our voice traffic. When you study voice video, when you talk about the collaboration voice video, when you talk about, voice packets, those voice packets are very, small packets, which I do not want to be overloaded with that, even that 4-byte long tag as well. Right? So this native VLAN was being used to, typically in older environment, we used to use this native VLAN to forward the traffic between IP phone to IP phone without being tagged, from one switch to another switch. But when it came, when the voice VLAN come into the picture, when the voice VLANs came into the market, this concept of native VLAN is not very useful nowadays. It's like native VLAN is more like, nowadays, native VLAN is more like a vulnerability that we have in our network rather than a feature that we have in our network. We used to use this native VLAN when it comes to voice in earlier days. There is an IP phone connected here. I want, when this IP phone sends the traffic, that traffic must pass out of this trunk link towards the another switch without any tag. So I will configure this IP phone maybe in VLAN 99, and I will configure that VLAN 99 as native on here. So when the traffic arrives onto this port, traffic belongs to VLAN 99. It will be sent untagged out of the trunk link towards the neighboring switch. Here also, the VLAN 99 is configured as native. Here also, the VLAN 99 is configured as native. So when the untagged frame arrives onto this port, it will belong to the VLAN 99 and will be sent towards the device in VLAN 99, which is another IP phone. But then came in the market this concept of voice VLAN, where we can define on the switch port a dedicated VLAN for voice traffic, which we call as the voice VLAN. So since then, actually, this concept of native VLAN is not very much useful, right? But yes, we can actually still use it to forward our voice traffic if you want. But since we have the dedicated voice VLAN, actually, we don't need to. So practically speaking, in today's network, we do not see much use of this native VLAN concept. And it's more like, in a modern day network, it's more like nowadays a vulnerability. It is more of a vulnerability than a feature in a modern day network. How voice traffic can be tagged, cannot be tagged, that depends on your configurations that you have done onto the port. We have different things, different concepts to handle our voice traffic. So voice traffic can be tagged, cannot be tagged, that depends on your configuration. Right? We can use native VLAN, we can use the command untagged, we can use .1p. We have different concepts for our, for handling our voice traffic. Maybe one day we will talk about it. But native VLAN is more like a vulnerability nowadays. Let me explain you why. Let me explain you how actually. Let's say, as far as the management traffic is concerned, we can also untag management traffic as well. Like if you want, like the management traffic needs to be untagged, yes, we can also untag the management traffic. Now, how this is a vulnerability nowadays? Let's say there is a server here. There's a server here. This server belongs to VLAN 33, and I want to attack onto this server. As an attacker, I'm going to connect myself onto your switch, port number 10. This port belongs to VLAN 100. I do not care. It doesn't matter to which VLAN this port is connected. The main point is this port is connected to this user, this attacker has connected itself onto the switch port. On that switch port belongs to VLAN 100, and VLAN 100 is configured as native VLAN here. Or let's keep it simple. By default, all the ports are in VLAN 1. So the user has connected itself onto a switch port. That port belongs to VLAN 1. And actually the same VLAN is configured as native VLAN because you never changed it. This attacker generates some traffic, which includes some malware, some malicious traffic. It generates that traffic. And this attacker itself is going to tag that traffic with VLAN number 33. Ideally, the end users, they do not send the tag traffic, but this attacker is using some sort of tool to tag that traffic with VLAN ID number 33. Attacker has generated some malicious traffic, malwares or something, virus or something, and it has added a tag onto the data number 33. Now, the attacker sends the data, traffic arrives onto this particular port. This particular port belongs to VLAN 1. This is not a trunk port. If this is not a trunk port, this port cannot read the VLAN membership. It will just treat it as a data. This will be treated just as a data. This port receives the data. The data will be considered part of VLAN 1. Why? Because the data is received onto a port that belongs to VLAN 1. It is not a trunk port, it is an access port. So when the data is received onto this particular port and the data is now being sent out of the trunk link, it will not be tagged because onto that trunk link, same VLAN you have configured as the native VLAN. So you sent this data as it is towards the neighboring switch. You did not tag the data with the VLAN number 1. You did not tag that data with the VLAN number 1. You did not tag that data with VLAN number 1. Why you did not tag the data with VLAN number 1? Because the VLAN number 1 was also configured as native onto that switch. Ideally, this switch was supposed to receive untagged frame on here, but the frame is not untagged in reality. The frame has already been tagged with VLAN number 33. And since it is trunk link, it will read that tag and it will forward that data towards the user, towards the server in that particular VLAN. And as soon as the data is received on here, you know what will happen next. So it's more like a vulnerability that can be used to perform some sort of attacks in your network. Earlier days, it was good. It was okay to be used for our voice traffic, for example, but nowadays it's just more like a vulnerability. If I have configured VLAN number 99 as the native VLAN and attacker comes to know about it, attacker will connect itself onto a port that belongs to VLAN 99 and it might perform it will be able to perform some sort of attacks towards your devices. The attacker will just generate the traffic. It will tag that traffic with a VLAN membership, such as VLAN 22. Traffic will arrive on here. This port is an access port, belongs to VLAN 99. Traffic will pass from the trunk link. Same VLAN is configured as native onto that trunk link. So the traffic will be sent as it is towards the neighboring device. When this neighboring device receives the traffic, it has a tag number 22. Traffic will reach towards the user in VLAN 22, and whatever type of attack the attacker wants to perform can be done. So it's more like a vulnerability. And I can show you that if I, for example, if I go on this particular switch that we have here, if I go on switch number 1, if I configure, for example, interface ETH0x2 switch port trunk native VLAN 10. If I configure native VLAN 10 here, I must configure native VLAN 10 here as well on switch number 5. So let's go on switch number 5. If you don't, STP will block it. If you do not do that, STP will block that port, saying that inconsistent VLAN. Show its spanning tree inconsistent port. It says that the port Ethernet 0x0 is blocked in VLAN 1 and VLAN 10 because of port VLAN ID mismatch. So we have to configure the same VLAN, switch port trunk native VLAN 10 here as well. So if you have configured native VLAN, for example, 10 here, you have to configure the native VLAN 10 here as well. And now when I send the traffic for VLAN 10, earlier you have seen that the tag was being added, but now if you go on host machine 1 and ping 192.168.10.2, the ping will exit out of this interface. Let the STP converge once. Let the STP converge once. STP unblocks the port. Do show a spanning tree, VLAN 10 for learning state. Let the port go into the forwarding state. Will take 30 seconds. Then you will be able to reach to the destination. Done. And now if you check the captures, on the capture, echo request, echo reply, you open this capture, there is no tag in it. Earlier, the tag was there, but now there's no tag in it. So traffic arrives onto this port. Port belongs to VLAN 10. Same VLAN is configured as native here. So the traffic will not be tagged. Untagged frame will be sent towards the switch number 5. Untagged frame is received on here. Untagged frame belongs to the native VLAN. What VLAN is the native VLAN? 10. So the data will be considered part of VLAN 10. And when the data exits out of this trunk link, what VLAN is configured as the native VLAN? 1. So the tagging will happen. The data will be tagged with VLAN 10 and sent out of this particular port. Tag will be read, and then the traffic will be passed towards the user in VLAN 10. Here only we change the native VLAN to 10. Na? Here still the native VLAN is 1. So when the traffic is passed, the tag will be added there in that case. You can also check it just in case if you want to check. You can capture interface Ethernet 0x1 and you can check that as well. Like if I am sending the data, if I'm doing the ping, whatever data exits out of here, that data still has the tag. Only on the trunk link where the native VLAN is configured as the same, the data will not be tagged. Other, it will be tagged as usual. So to support the untagged frame, we can have the native VLAN concept, which was very popularly used before the voice VLAN came into the picture. But nowadays, it's not that much popular. It's more like a vulnerability, so it's always recommended. It's always recommended that you configure any random VLAN as the native VLAN on the trunk link, or maybe let's say you are using a VLAN, a certain VLAN for the management, you can configure that as a native VLAN. But remember, if the attacker gets to know about that VLAN, it still can perform the attacks based on the same. The best solution will be do whatever configuration you want to do. The best solution will be VLAN.1Q tag native. This is the best solution. VLAN.1Q tag native. VLAN.1Q tag native. It means now you instructed the switch to perform tagging for native VLAN as well. So now if I send the data, you will notice in the capture, you will notice that the data that I just sent right now, this data is now going to be tagged as well, even though the data belongs to the native VLAN. So if I want to prevent any sort of that VLAN hopping attack, where the attacker has added the VLAN onto itself and then sending the data, that sort of attack, if I want to prevent, I can actually enable this command called VLAN.1Q tag native. This command instructs the switch to add the VLAN tag for the native VLAN as well. This is also you can do. So now the native VLAN traffic is also tagged. So there will not be any vulnerability, if I say, because of the native VLAN configuration. Forget about configuring any random VLAN as the native VLAN and all. So you can also use this command, right? So this is the use case of the native VLAN. We'll talk more about the native VLAN tomorrow. We'll talk use case, actually how we can use the native VLAN in today's environment. We will talk about the use case of the native VLAN as well, not from the voice point of view, but from a general point of view. We'll talk about that as well. We'll talk more about a native VLAN, and then we will move on to the other protocols such as DTP. So far, we have covered up to the VLAN, native VLAN concept.